perimeters and areas of similar figures, okay? Similar meaning they're proportional. Their angles will be the same. Their sides will be proportional. We've talked similar figures before, right? Remember when we did AA similarity, SAS similarity, ASA similarity? Yes, I am recording. Thank you. So with similar figures, like I said, your angles will be congruent. Your sides will be proportional. Okay, these are going to be similar figures. So first of all, if you look at these two triangles, we're just going to kind of break it down and see how this comes into play before I tell you how this works. Okay, look at the two triangles given. Can you tell me a scale factor for those two triangles? 1 to 2, yeah. 3 to 6, right? You just find, corresponding sides, and you set up the ratio. Try again. So 3 to 6 is a scale factor of 1 to 2. Okay, so that's the scale factor for those two triangles. Okay, now let's look at the first triangle. Can you tell me the perimeter of that first triangle? What is it?
9.
It's not 9, it's 12. 3 plus 4 plus 5, right? Add up the three sides. 3 plus 4 plus 5 is 12. Not the doctor. The second triangle. Can you tell me that perimeter?
24.
6 plus 8 plus 10 is 24. Okay? So now let's check the ratio of their perimeters. 12 to 24 is what? 1 to 2. Oh, look at that. That was our scale factor. That's a fun fact. Okay, now look at the areas of the two triangles. How do you find the area of that first triangle?
3 times 4. Half.
Times a half, right? 1/2 times the base times the height. So 1/2 times 4 times 3, or 6 square units. Okay, now look at the second triangle. What's the area of that triangle? 1/2 times
6 times
8 times 6, or 6 times 8. 1/2 times 8 times 6 is 24 square units. So the ratio of their areas, the comparison of those two areas, would be 6 to 24. What is 6 to 24? 1 to 4. Okay, so here's what I want you to look at. You have a scale factor of 1 to 2, a perimeter ratio of 1 to 2, and an area ratio of 1 to 4. That relationship will happen every single time with any figures you use, as long as those figures are similar. Here's basically what it's saying, okay? If your scale factor is A to B, then when I say what would the perimeter ratio of those figures be, the perimeter ratio is going to be that same ratio. So if your scale factor is 1 to 2, your perimeter ratio is 1 to 2. If your scale factor was 1 to 5, your perimeter ratio would be 1 to 5. Okay, so a perimeter ratio will be the same as a scale factor. And then the area ratio will just be squaring both of those, right? 1 to 2 squared is 1 to 4, which is what we got in that last problem. Okay, so just keep in mind, this is basically what we're saying. Scale factor, A to B. Perimeter ratio, A to B. Area ratio, A squared to B squared. Okay, those values will always hold steady. Okay, so let's say you get to a problem like this first example then. It says those two figures are similar, meaning proportional sides, right? I want to know what is the perimeter ratio and what is the area ratio. So let's just start with a scale factor. What is your scale factor?
2 and 3.
it's 6 to 9. And we always reduce, so it's 2 to 3. Okay, so my scale factor is 2 to 3. What is my perimeter ratio then? If I'm going to compare the ratio or the perimeters, it's going to be the exact same thing, 2 to 3. Okay. What is your area ratio going to be? 4 to 9. You're going to square your scale factor or your perimeter ratio. 2 squared to 3 squared is 4 to 9. Okay, does that make sense? Questions on that at all? Okay, look at example 2 here. This says the area of the larger parallelogram, so I put it inside, is 96 square inches. What's the area of the smaller? Now, normally, you found the area of a parallelogram by using what formula? Base times height. Do you have a base for that first one?
No.
You do? Yeah, 6, right, is your base. Do you have a height?
No.
We don't have a height, okay? But here's the beautiful thing. Because we know that these are similar figures, I should have written that. These are similar. Sorry, I didn't tell you that. I'm telling you that now. Those are similar figures, okay? Because they're similar, then we know their area ratios have to be the square of their scale factor, right? Can you tell me the scale factor of these two figures? 6 to 8. Your scale factor is 6 to 8. Now here's the deal. You must reduce, right? So it's 3 to 4. Your scale factor is 3 to 4. So what is your area ratio? Right. You are going to square that 3 to 4. So 3 squared to 4 squared is 9 to 16. Okay, that's your area ratio. We don't want the area ratio. We want the area of the other figure. Does anyone see a way that you could set this up to find this missing area? I'm going to give you a second to think about it before we get an answer. We know an area ratio. We know one of the areas. How could you set it up to find the other area? Eeny, meeny, miny, moe. Go ahead, Luke. I saw yours first.
And 96 divided by 16, and then after you find that, multiply 9 by the answer.
Okay, essentially, you're setting up a proportion, right?
Yeah.
You're saying 9 to 16. Where does this 96 have to go in this proportion?
Denominator.
On the bottom, right? Because it's the bigger one, so it needs to go across from the bigger one. If you put it on top, you're gonna get the wrong answer, okay? So it's gonna be area ratio is equal to the missing area over the area that we know. And then you just cross multiply it. So this is 16x equals 96 times 6 is what? Or not times 6, sorry. 96 times 9 is 864. Okay, so divide by 16 and you get x equals 54. So the area of that smaller figure is 54 square inches. Does that make sense? It's a lot of steps, right? You find the scale factor, you find the area ratio, and then once you find the area ratio, then you'll set up the proportion, okay?
Wait, was what I didn't find?
What? I'm sorry. Why not?
The other paper this paper got stuck in the printer in A. And so me and Grace were trying to figure out how to get it, but everything is here.
It worked? Did it print fine after it got stuck then? It wasn't like a wrinkled, what printed?
Just the original's a little wrinkled.
Okay, no worries. Okay, sorry, who was asking me? Yeah,
Wait, so is the way that I did, does that still work? Doing 96 divided by 16, then the answer, then multiply that by 9.
96 divided by 16. Yeah.
Okay.
Mhm. Yeah, you essentially set up a proportion in your head, right? Okay, example 3 here. You have a group of high school students. This is our friend Daniel right here. Cultivated a plot of land and harvested 13 bushels of vegetables that they donated to a food pantry. Next summer, the city is going to let them use a larger, similar plot of land. In the new plot, each dimension is 2.5 times the corresponding dimension of the original plot. How many bushels can they expect to harvest? Okay, now there's a lot going on here. So stop and think through this. What are your words? What's going on? It says in the new plot, each dimension is 2.5 times the corresponding dimension of the original one. So whatever your original figure was, we're saying the new one is 2.5 times bigger than the original, right? So if the original was 1, the new one would be 2.5. Does that make sense? So what's your scale factor?
2.5.
You could call it 2.5. I'm going to call it 1 to 2.5 just because I'm going to go from smaller to bigger the whole way. But if you went bigger to smaller, your scale factor is 2.5. Okay? Okay, so we know our scale factor. When you harvest land, do you just harvest around the edges of your land? No, you fill it in, right? We want as much produce out of this as we can get. So what are we working with there? Is that perimeter or area? Area, okay? Our scale factor is not an area ratio. How do you turn that into an area ratio?
Square it.
You square it. 1 squared over 2.5 squared is 1 over 6.25. Okay, so this is our area ratio. If that's our area ratio, and they told us they harvested 13 bushels of vegetables in the first time, how many can we expect? What does your proportion look like? 1 over 6.25 equals what over what?
3 over x, or 13 over x.
13. So the 13 was the original, right? 13 went with that one. So it needs to go across from the 1 and then x on bottom. Does that make sense how we're coming up with all that? Okay?
X equals 13 times 6.25.
Yes. So we multiply x is equal to 13 times 6.25 is 81. That's 18. 81.25 bushels. So if they really get 2.5 times the size, the dimensions, they'll get 81 bushels instead of 13 bushels. That's huge. Hey, I'm working up here. You should be working with me. Right? Yeah, do that. Any questions on that? Okay. I want you to try this one on your own. This is different. It's a little different. You kind of have to work backwards, but I want to see if anyone can figure it out without me even talking you through it. It says the area of 2 similar triangles are 50 square centimeters and 98 square centimeters. What's the area ratio? What's the scale factor? And what's the perimeter ratio? Okay, remember you're working backwards now. Kind of have to think in reverse a little bit. See if you can work that out and find your 3 ratios. We're looking for a scale factor, a perimeter ratio, and an area ratio.
What if these ones are like?
Okay. Tell me, not the whole process, tell me your first step. What'd you do, Bella?
You set up 50 over 98
Okay, 50 over 98 is what?
is our area ratio.
That's your area ratio. Okay. Is that your area ratio, though?
No, you have to simplify.
Have to simplify it. So if you simplify that, what do you get?
25 over 49.
Yes. Okay, so your area ratio is 25 to 49. Who can give me the next thing you did? Go ahead, Bella.
You square root them.
Right, so if it's an area ratio, this is a squared over b squared, which means if I want to know a over b, which is what I'm trying to find with my scale factor and perimeter ratio, I would have to square root that, right? So the square root of 25 and the square root of 49 gives you 5 to 7 for your scale factor, okay? What's your perimeter ratio? 5 to 7. The perimeter ratio will always be the same as the scale factor. Okay? So just pay attention to the wording. Wording is huge in these problems. If they're giving you area, you got to work backwards and square root. If they're giving you scale factor, you work forward and you square. Okay? So take your time with that. And then note 10.5 has trigonometry in it. You're going to love it. Why do you keep coming here? Are you charging? Gotcha. So good to see you so many times today.